Hey everyone, Mr. Voikin here, Unit 10, Lesson 4, Systems of Linear Equations, and we're going to be doing elimination. So the last one was substitution, and this one's going to be elimination, so getting rid of something. Okay, so let's take a look at class example number 1, and we've got two equations right here. We got 2x plus 7y equals 13 and 3x minus 7y equals 2. Now if we stack them on top of each other like that, basically what you should be able to recognize is that right here we've got a positive 7y and a negative 7y. So if I just take those two equations and I literally just add them together, okay, so on this side, on the right side of the equal sign, it's 13 plus 2, which is 15. And on the left side, we get positive 7y plus negative 7y, which eliminates it. So literally those are gone. And that leaves us with 2x plus 3x, which is 5x. At this point, it's easy to solve for the x by dividing by 5, and we get x equals 3. Okay, if we're going to verify this solution as it's asking us to do in part C, first of all we need to calculate the y value. Okay, so I need to take that x and substitute it into one of the equations. So 2 times x, which is 3, plus 7y equals 13. 2 times 3 is 6, plus 7y is 13. I'm going to subtract 6 from both sides, and I'll end up with 7y equals 7. And in this case, y equals 1 if we continue with the math there. So now that I know x is 3 and y is 1, we can verify in both equations. So we'll take the first one, which is going to be 2 times x, which is 3, plus 7 times y, which is 1, and that should equal 13. 2 times 3 is 6, 7 times 1 is 7, and 13 equals 13. Verified. Okay, just do the same thing in the second equation. So we're essentially going to get 3 times x. So 3 times x, which is 3, minus 7 times y, which is 1, and that should equal 2. 3 times 3 is 9, minus 7 equals 2. Is that true? Yes, 2 equals 2. Verified. All right, so let's move to class example 2, and you can see we have two equations again stacked on top of each other. I've got a 2x in the top one and a 2x in the bottom one, but it's not like the last one where it was a positive 7y and then a negative 7y. These both happen to be positive. Now, when we had the opposite signs, we added them together, which was able to eliminate it. So we're just going to, in this case, subtract the two. So in this case, on the right side of the equal sign, 6 minus 4.5 is 1.5. 6y minus 3y is going to be 3y. And 2x minus 2x will eliminate the x's. Okay, now we want to solve by dividing both sides by 3, and I end up with 1.5 over 3, which you should recognize 1.5 is half of 3. So really what we end up with is y equals 1 over 2. Okay, so now that I know y is equal to 1/2, again, I just need to go back into one of these original equations and substitute y with 1/2, and that will allow me to solve for x. So I'll use 2 times x plus 6 times y, which is 1/2, equals 6. 2x, 6 times 1/2 is going to be 3, equals 6. Subtract 3 from both sides. I've got 2x equals 3, and divide both sides by 2, and we get x equals 3 over 2. Okay, and now that I know that y is 1/2 and the x is 3 over 2, we can go into verify our work by substituting those values into the original equations. So I get 2 times x, which is 3 over 2, plus 6 times y, which is 1 over 2, and that should equal 6. So 2 times 3 is 6, divided by 2 is 3. 6 times 1 is 6, divided by 2 is 3. Does 3 plus 3 equal 6? Yes, sir. Okay, and the second equation should work out. Pretty certain of that. What do we have? We got 2x, and x is again 3 over 2, so 2 times 3 over 2, plus 3 times 1 over 2, and that should equal 4.5. So 2 times 3 is 6, 6 divided by 2 is 3, plus 3 times 1 is 3, divided by 2 is 3 over 2, and again, very simple math, and you should be able to see that right away. 3 over 2 is the same as 1.5. So if we're the answer on the right side is a decimal, 4.5, I will format that as a decimal as well. So we get 3 plus 1.5, which is 4.5, and 4.5 equals 4.5, verified. Okay, let's look at this example right here. So we have two equations, and it tells us to solve by eliminating b. Now, if we look at b, we've got a positive 3 on the top equation and a negative 7 on the bottom. But the coefficient in front needs to be the same. So essentially what I'm going to do is multiply the top one by 7 and multiply the bottom one by 3. So if I go in here and go, the top one's going to be 7 times 5a plus 3b equals 3. I'm going to end up with 35a plus 21b equals 21. And on the second equation, I'm going to multiply it by 3 times 3a minus 7b equals 81. And that's going to give us 9a minus 21b equals 81 times 3. So let's go 81 times 3, 243. And now what I'm going to do is I'm going to be, we've got the same coefficient in front of b. They're opposite signs, so we're going to be adding them together. So I'll move that over. Move that over, and I'm gonna just move these around. So I'll take like this one right here, move it right there, and I'll take this one right here, move it underneath, and we are going to, like I said, add these together. So 243 plus 21 is going to be 264. We're going to kill the b's here, and 35a plus 9a is going to give us 44a. And now I want to divide this 264. We'll clear that. 264 divided by 44. Does that give us a whole number? Yes, it gives us 6. So basically we end up with a equals 6. Okay, now that we know what a equals, again, simple substitution, and we'll be able to solve for the b. Okay, so I'll take my original equation right now, which 5a, and sorry, a is equal to 6, so 5 times 6 plus 3b equals 3. We get 30 plus 3b equals 3. I'm going to subtract 30 from both sides, so I'm going to get 3b equals negative 27, and divide by 3 on both sides. and we're going to get b equals -9. So now I've got a as 6 and b as -9. Okay, and basically we've done part C and we've done part D, and there is no part E. So the only thing left to do at that point, again, would be to verify it. And it's not asking us to do it here, but I'm just going to make sure. So 5 times A, which is 6, plus 3 times B, which is -9, should equal 3. 5 times 6 is 30, plus, and this would be a negative actually, minus 27 equals 3, and it's true. So I'm sure the other one would work out as well. Okay, class example 5, we've got 2 more equations here, and you should note that they are not in the same format and they do not share similar coefficients in front of the x and y variables. So the first thing we're going to do is just reformat these so that they are in the same format. So this one right here, I will just move the 13 to the other side by adding 13 to both sides. So I'm going to get 4x plus 2y equals 13. And the other one, I'll move the 5y over to the left. So we're going to get 3x minus 5y equals 26. So now that both of those are in the same format, we can line them up like so and recognize that, again, that the coefficients are not the same. So in this case, what I'm probably going to have to do if I want to eliminate x is to multiply the bottom one by 4 and the top one by 3. So let's go ahead and do that. So I'll move this one over and take this one up here. So again, the first one I'll multiply by 3, and the second one I'll multiply by 4. So this is going to give us 12x plus 6y equals 39, and on the other one we're going to have 12x minus 20y equals, and 26 times 4 should be 104. Yeah, that should be right. Okay, and now that we've got similar coefficients, we can stack these again. So I'll move this one over here, and we just have to figure out whether we're going to add or subtract, and because we got a positive 12 and a positive 12, I will subtract these two. So starting over on the left, we've got 39 minus 104. So we actually end up with a negative 65. And I've got a 6 minus negative 20. So that's going to be plus 20. So I've got a 26y, and the x's will cancel because it's 12x minus 12x. And now I can just take this, I'm just going to make it a little bit smaller so we got some space here. Okay, and if I divide both sides by 26, I get negative 65 divided by 26, and we end up with a y equals negative 2.5. Okay, so now that we know y is a negative 2.5, we are going to want to substitute that y value into one of the equations to solve for x. So for x plus 2 times 2.5, or negative 2.5, minus 13 equals 0, and we're going to have 4x minus 5 minus 13 equals 0, and 4x minus 18 equals 0, 4x equals 18, and we're going to divide everything by 4, and we're going to get 9 over 2 as a reduced fraction, and 9 divided by 2 is 4.5. So the x is equal to 4.5. Okay, and both negative 2.5 and 4.5 could be represented in fractional form as well if you were asked to do that. Okay, so now that we have values for x and y, the last thing that we always need to do is to verify that those numbers will work in both equations. So I'll just move these out of the way, and we'll do a little verifying here. So we'll take the first one, which is going to be 4 times x, which is 4.5, plus 2 times y, which is negative 2.5, minus 13, and that should equal 0 all the way down. So the left side should work out to be 0. 4 times 4.5 is going to be 18, plus 2 times negative 2.5 is going to be a negative 5, minus 13, and again equals 0, and 18 minus 5 minus 13 is 0, so we get 0 equals 0, and it is verified. And if we did that again on the second equation, we should end up with the same result. Okay, on the last example here, number 6, we got two equations again, and they're just a little bit more complex. You can see that some of the terms are in fractional form. So first thing we need to do is eliminate the denominators so that we can work with these equations a lot easier. So to do that, we just need to find a common denominator on each of them and multiply that common denominator by every one of the terms. So on the first one right here, we've got a 3 and a 5. A common denominator is 15. So we will multiply 15 by that, and that. And on the second one, we've got a 5, 5, and a 2. So we will multiply that by a 10. Okay, so that'll be the first thing we're going to do. So if I now multiply 15 times x minus 2 over 3, I'm going to basically end up with a 5 up top times the x minus 2. And we can lay that out like this and go to the next step, or you could directly go to a 5x minus 10 right there. So I will do that. So basically what I'm going to do first is go like 15 divided by 3 is 5. So I'm multiplying this first term by 5, and that allows me to have 5x minus 10. Okay, the next term we're going to multiply by 15 again, divide by 5, so we're going to be multiplying it by 3. Now, recognize there's this negative sign in there, so whatever we put inside here, we're going to have to change the signs of that later. So it's going to be 3y, and don't forget 15 divided by 5 is 3. 3 times 2 is 6. Okay, and that equals 2 times 15, which is 30. Okay, now, like I said, it's this little minus sign right here that's going to change the signs in here, and that one would sort of become a plus, right? So if I was to rewrite this, we're going to have 5x minus 10 minus 3y minus 6 equals 30. Okay? And now what I need to do is sort of put this into the format that we've had before. So this would be 5x minus 3y minus 16 equals 30. I'll add 16 to both sides, and I'll end up with 5x minus 3y, if I add 16 to both sides, equals 46. Okay, so that's the first one, and I'll just sort of move this out of our way. Okay, and we'll take a look at the second one. So we're multiplying everything by 10. So 10 divided by 5 is 2, and 2 times 3 is 6. So we're going to multiply everything in that first bracket on the first term by 6. So we're going to end up with a 6x plus 6. And for the second one, we've got that minus sign there again. So we'll put whatever we figure for the second term into that bracket and then change the signs. So 10 divided by 5 is 2. 2 times 4 is 8. 8 times the y is going to be 8y, and 8 times the negative 3 is going to be a negative 24. Okay, and on the outside, we've got 10 divided by 2, which is 5, and 5 times 21 is going to be 105. Okay, now I'm going to deal with this, the two brackets right here and the negative inside. So basically it's going to become a negative 8 and a positive 24. And I'll just rewrite this as 6x plus 6 minus 8y plus 24 equals 105. We'll put that into the same format so we can compare and do some elimination with the two equations. So I've got a 6x minus 8y plus 30 equals 105. I will minus 30 from both sides. So I've got 6x minus 8y equals 75. Okay, so let's take this and we'll resize it as well. Okay, and we'll take these two equations that we have, this one and that one, and we'll restack them here and compare them so we don't have any similar coefficients. So again, I'm going to have to multiply both of them by a value that will create similar coefficients or the same coefficients. So I'll eliminate the x in this choice here. So I'll multiply the top by 6. And the bottom we will multiply by 5. And we should end up with a 30 right there. So let's just move this one down and out of the way. Okay, so we'll start with the first one, which we have 6 times 5 is 30x. 6 times 34 is going to be negative 6 times, oh, that's not 34, that's a negative 3y. 6 times negative 3 is negative 18y, and 6 times 46 is going to be 276. And the second one, we're going to end up with 30x minus 40y, and 75 times 5 is going to be 375. Now that we have similar coefficients, we can take these two right here and stack them. Let's move this one up there. Okay, and what are we going to do? Because they're both positive, we are going to subtract. Okay, so 276 minus 375 is a negative 99. And 18 minus negative 40 becomes negative 18 minus negative 40 becomes negative 18 plus 40. So we end up with a positive 22y. And the x's are eliminated. And I now divide everything by 22. Oops. And 11 can divide into both of those, so we should end up with y equals negative 9 over 2, which is the same as a negative 4.5. Right, and moving along again, because we have the y value, we now need to figure out the x value by substituting the y value in there. And I don't want to use one of the equations that we were originally given with all those fractions in there. It's just going to be a little bit too much math. So I'm just going to go with this one right here, which was 5x minus 3y equals 46. And now if I substitute the y with a negative 4.5, and now all I got to do is take 4.5 and multiply, or negative 4.5 and multiply it by a negative 3, and we're going to get a positive 13.5 equals 46, and I got a x right here. So I'll minus 13.5 from either side. So 46 minus 13.5 is going to be 32.5. So we're going to end up with a 5x equals 32.5. And now I want to divide everything by 5. And we end up with an x equals 6.5. Okay, and as we've done on every other equation, let's just verify that that is correct. Just move these out of the way. And we'll take, again, one of these equations that we worked on. I'll choose the bottom one in this case. So we have 6 times x, which we said was 6.5, minus 8 times y, which is negative 4.5. And when we calculate all that, it should equal whatever's on the right, which is 75. Okay, so 6 times 6.5 is going to be 39. And we're gonna, now we got a negative times a positive, so we're gonna, or negative times a negative, so we're gonna have a positive, and 8 times 4.5 is 36. And we want to see if that equals 75, and yes, 39 plus 36 is 75, and 75 equals 75, so that has been verified. Okay, that was a lot of work on this lesson, and now we're moving into the assignment on page 635, and there's lots of work here, and the answers are at the end right here on page 640. See you in class.